Okay, the question here says, what is the smallest integer, the smallest positive integer k, such that the product 1575 times k is a perfect square? What is the smallest integer? Anyway, before I attempt this question, let me explain to you what we mean by a perfect square. So a perfect square is just let me say a layman's way of explaining the perfect square is a perfect square is any number that can be written as the square of an integer. Okay, let me write that down because if I'm saying it, you might not really get the picture. So let me say a perfect square now. So a perfect square. So we said a perfect square is just any number that can be written as the square of an integer. So when I say integer, like I said, I simply imply a whole number. I'm just going to keep on repeating integer whole number because I believe some people might not be too used to this, so I need to get them used to the term integer. So any number that can be written as the square of another integer is called a perfect square. So an example you can guess. So 4 is a perfect square. Why? Because 4 can be written as a square of a whole number. That's the square of 2. What of 9? Let's see. 9 also is a perfect square. Why? Because it can be written as the square of an integer. But let's see 10. Now 10 can be written as, because 10 is just the root of some number or something, so like root of 10 squared or something like that, but this is not what we need. We need the square of a whole number. So 10 cannot be written as the square of a whole number, so because of that we would say that 10 is not a perfect square. Alright, another very good way to determine if a number is a perfect square is this. So let's look at let me draw it here. Let me do it like this. So let's look at 9. So a very good way to know if a number is a perfect square is by going through the long factorization. So you have 9, so you want to find 3 goes in 9, 3, and then 3 goes in 3, 1. So to find the prime factorization or the prime factors of 9, so like we usually do, we go 3, 9, 3, 3, and then you have 1. So all the prime factors must occur in pairs. So this is 3 squared. You can see that. So for each number you have, it always has a pair. The same thing happens for 4, and then on like that. So for all perfect squares, each of the factors, they occur in pairs. They occur in pairs. Alright, now you understand what a perfect square is. So now what it says here is, what is the smallest positive integer such that the product 1575 times k is a perfect square? Anyway, for this to be a perfect square, let me first try and break down 1575 and then see what we're going to result in, and then we'll know what next step to take. So looking at 1575, so the number we are taking into consideration now is 1575 times k. So times k. So we want to take into consideration 1575 first. So we have 1575. When you go through the long division, that's to find the prime factors of 1575. So I'm going to start with 3. So you're going to start with the lowest number, which is 2. But since this is not an even number, so I'm going to start with 3. So 3 is divisible by 1575 is divisible by 3. So when you divide this number by 3, what you'd obtain is 5. So 3 and 7, this is going to be 2, 5. And then 3 is also divisible again, so you'd have 1, 2, 5. So 5 goes, and then you have 35, and then 5 still goes, you have 7, and then you have 7, you have 1. So now what we have here is 1575. So what you'd observe here is that 3 occurs in pair. You can see 3 occurs in pairs. This is going to be 3 squared. 5 occurs in pairs, so this is going to be 5 squared. but then 7 is the only number that does not occur in pair. So that implies that for 1575 times k to be a perfect square, then 7 must occur in pair. That is, 7 must have another 7. So for this to be a perfect square, it implies that k must be 7. That is, if this was 1575 times 7, so if this was times 7, then we would have divided by an extra 7 to make it a perfect square. So that implies that the number which we needed k to be, that is the lowest number anyway, is 7. So the solution to the problem is 7. Like I said, it says what is the smallest positive integer. So you note k could be another bigger number. Like k could be let's say we could choose k to be 7 times 4. K could be 28, because when you multiply by this is the same thing as 7 times 2 squared. So this also works, but then we needed the smallest positive number, because if you have something like this, so let's not confuse things here, but the main picture is the smallest positive number we needed was is k equals 7, and that's why this is the solution to the problem. Thanks for watching.